Hi everyone. In this video, I'm going to tell you about my first Houdini plugin, which has been in development for a very long time, and now I'm finally ready to share it with you. The plugin is built completely from scratch using the HDK and is designed to make Boolean operations much faster and more efficient. I hope you like it. Enjoy the video. After following the instructions in the file included with the plugin on my Gumroad, you'll be able to find this node by pressing the tab key in the SOP context. Currently, there are 5 main operations available: union, subtract, intersect, cut, and shatter. Let's take a look at how they work. You can subtract objects and invert the operation using the subtract geometry dropdown and the reverse option where available. The cut and shatter operations are the fastest among them as the processing is performed on only one of the geometries. Next, you have 2 main parameters that affect intersection precision and seam stitching. In most cases, you don't need to change these settings. Precision parameter, the overall accuracy of the calculations. A smaller value increases the mathematical precision, allowing you to preserve the smallest fragments at the intersections. Fuse points, parameter, the welding radius for points along the resulting seam used to prevent any gaps in the mesh. The next block of parameters is responsible for removing artifacts in areas where the edges of 2 objects perfectly match. I'll show you how they work a little later. The next block is responsible for triangulating geometries at their intersections. Preview, triangulation, displays the initial triangulation of the geometry without performing the Boolean operation itself. Triangulate selects the subdivision algorithm, for example, to avoid long or distorted triangles. Connect points selects the triangulation method for primitives at the intersections. The next block is responsible for cleaning up the topology after the Boolean operation. Dissolve edges removes unnecessary internal edges, restoring clean n-gons. Remove zero faces automatically removes garbage micropolygons with 0 area. Remove overlap removes overlapping faces. Clean points aligns and cleans up excess points along the seam after dissolving the edges. As you can see, by increasing this maximum angle threshold, only the points with an angle greater than the specified limit will remain. Connect edges. This is the search radius for connecting edges to each other if any remain disconnected after stitching the points. The next block of parameters lets you create specific groups at the intersections. Point group, the group of all points that make up the seam line. Point group A and point group B, seam points formed exclusively by object A or object B, useful for finding out which object cut the other. Edge group, the group of edges along the seam line, which is perfect for a bevel node. Slice group, the polygons generated directly on the cut surface. Prim group A and prim group B, the remaining polygons from the original object A or B. I'll leave a group of edges on the seam so I can see where we have intersections. Next is the attribute transfer block. The most complex and time-consuming operation is the UV attribute transfer. Now I'll add a UV attribute so you can see how it works and how it affects the Boolean computation time. This works exactly the same as the native Boolean in Houdini. Now I will show you how this attribute affects the speed of the Boolean. As you can see, we lose performance when we transfer this attribute, so keep this in mind, especially if you're animating the incoming geometry. Let's compare the performance of 2 nodes. You can monitor the FPS value in the viewport to see the tool's performance. As you can see, the built-in Boolean takes almost twice as long, but that doesn't make it worse, because it calculates self-intersections. This is something you should keep in mind. Solid Boolean cuts everything but doesn't solve the self-intersection problem. This feature will be added in future updates or perhaps as a separate post-process tool before the Boolean operation itself. The next block allows you to transfer groups that were previously on geometries, except for edge groups. This way you can keep or clear the incoming groups that were there before if you need to. Using input groups, you can restrict the participating primitives in a Boolean operation. Right now, you can see an issue in the cross-section because the incoming geometries in the first input intersect with each other. To fix this, you can use the incoming groups to cut the specific mesh. In situations like this, the native Boolean actually performs better. Now, I will show you this problem in more detail. As you can see, solid Boolean does not currently handle self-intersections. In some cases, the built-in Boolean might not produce a completely clean result, as you can see in this example. Solid Boolean will perform flawlessly if your geometry has no self-intersections, and it does it up to 75% faster on average than the built-in Boolean. Now let's take a look at how it handles coplanar faces. Unlike the built-in Boolean, it allows you to choose whether to keep the intersection zone from geometry A or geometry B. Now I'll show you how the parameters in the coplanar block work. Now I'll add a tiny rotation on one axis to stress test the Boolean and introduce floating point noise at the intersections. The shift parameter acts as a bridge between 32-bit data noise and the 64-bit precision of the engine. It controls how much and in which direction we offset the coplanar faces along their normals. This slight shift ensures they no longer sit perfectly on top of each other, allowing the 64-bit solver to resolve the topology cleanly and completely eliminate z-fighting. There's also a correction parameter that physically shifts the points to eliminate floating point noise when surfaces are very slightly offset from each other. However, this parameter can slow down the Boolean computation. It's a temporary feature that I decided to keep for now, but it will likely be removed in future versions because it's redundant, especially since the shift parameter already does its job perfectly without physically altering the geometry shape. That's all for now. I hope everything was clear. In any case, the Discord link is available below where we can hang out and discuss any questions you might have. So make sure to join in. There will be more assets and plugins coming to the channel soon. Thank you all for watching.